Hey everybody. So we're going to do a quick solution here to this inequality x cubed plus 3x squared minus the x minus 3 greater than or equal to 0. And I'm a big believer that we should be using tools that we've developed earlier to help us move forward here. So what I'm going to do is I'm going to use the graph of this function to help me answer this. So I'm going to introduce a y here. But notice in the original inequality, there's no y in there. So I'm going to answer my question with that understanding that there's no y there, but just I'm going to use the graph of this as a tool. Now, for me to graph this, one of the first things I want to do is going to find the x-intercepts. So what we'll do here is we'll set y equal to 0. And then I'm going to factor this. Now I've got 4 terms here. It's a cubic. I'm going to try factoring by grouping. So I'm going to group together the first 2 terms. I'm going to put a big old plus sign in between and move the last 2 terms over. Now, I've really done nothing to that, okay? It's like I'm adding a negative there, but I have done nothing. Now what I'm going to do is take out what's common out of both of those two sets of parentheses. And in the first one, there's a common x squared, which leaves me with x plus 3. And then here, there's a common negative 1. So I'm really just going to take out a common, that negative there. That's going to leave me with an x plus 3. Because I get an x plus 3 common to both terms now, I can factor out that x plus 3 from that first term. That's going to leave me with just the x squared minus, and from the second term, all I'm going to get out of that front there is that, that 1, that negative 1, if you will. This is great. I can take this one step further because I'm left with that second binomial there is a difference of squares, so x minus 1, x plus 1, which tells me that my solutions here, my x-intercepts are going to be where x is equal to negative 3, 1, and negative 1. So those are going to correspond to my x-intercepts, okay? My x-intercepts here, negative 3, 1, and negative 1. So graphically speaking, what we've got here is a graph that's going to cross the x-axis here at negative 3, negative 1, and 1. Each of those zeros has a multiplicity of 1. Okay, that when it's in factored form, the exponent on every one of those things is 1. So that means something about how it interacts with the x-axis. We'll talk about that in just a second here. It's also got a positive leading coefficient. So that means the motion of this cubic is going up. Now, this is all stuff that is assumed that you've worked through before here. So that means the graph is going to come up, pass right through the negative 3. It's going to come down right through the negative 1, and then back up right through the 1. That is the general look of our cubic. The question that we're being asked is, where is that function? For what values of x is the y coordinate greater than or equal to 0? And so I'm basically asking, where does this function end up in either quadrants 1 or 2? And that's actually easy to figure out here, because in order for it to be either in the top of the graph or below the graph, I got to look at how it crosses the x-axis. The x-axis is that door. So any value of x to the left of negative 3, notice that the graph is below. If I simply look at negative 3 and look to the left of it, the graph is below the x-axis. But between negative 3 and negative 1, it's above. Between negative 1 and 1, it's below. So that's no good. And then to the right of 1, it works. So what I'm looking for here are values of x in between negative 3 and negative 1, together with values of x greater than 1. But I'm going to go one step further here, because the question included the 0. The original question included the 0. So I can actually include those endpoints because the y coordinate is going to be 0 there. And so that's my answer. And I might write this in interval notation, say from negative 3 out to negative 1 inclusive, and then union from 1 out to infinity. And remember, we're going to use soft brackets on the infinity there. And so there's my solution to this inequality.